Okay, good morning, everyone. Um, I hope you're enjoying your snow day. I figure you're sitting at home watching TikTok or whatever teenagers do in the 21st century with their time. Nothing productive, of course. I'm going to change that this morning because while I'm recording it this morning, you can watch it when you want. But yeah, I thought, why waste this opportunity to have a lesson here? And you're bored anyway, so you're welcome. I mean, you should be so thankful you have a science teacher that takes care of you even when you're not here. So let's get right to it. Oh, don't forget, there's a quiz tomorrow. The quiz today, obviously, you get 1 day extra to prepare. Use the practice quiz. So that practice quiz is in here. Yeah, it's one of these things. Yeah, here. Use this as your practice quiz. So make sure you know what you're doing. Okay. I'll post answers at some point to this practice quiz today, and then that gives you a chance to do it. But your quiz will be basically identical to this. The only thing I'm going to change is the reactions themselves, so just to mix it up. But other than that, you should be prepared to balance the equations and also predict the products, and also to be able to tell whether a reaction happens or not based on the rules, which is the solubility rules and also the list of active elements on the periodic table. So anyway, so we've been practicing that. So hopefully you'll be able to do that here. Don't forget, there's a few things also like the decomposition of a carbonate, the decomposition of hydroxide. Okay, so don't forget those. Those are also going to be included. All right then, so I won't waste any more time. Let's get right to the lesson for today. And the lesson for today is very straightforward. It's about something you might have heard of before, called the pH and the POH scale. Probably the pH scale you've heard of before. But I won't take too much time with it. I just want to remind you, and hopefully this will work for me without too much technical difficulty, so just bear with me here. My pen, I feel, is a little bit like fragile here this morning, so I'll give it a try. All right, I just want to remind you the definitions that we've talked about here so far. So we've talked about what acids are, and there are basically two definitions for an acid that we look at in grade 10. There's a third one you'll look at in grade 11, the Lewis definition, but anyway, we won't worry about that in grade 10. But the two definitions that we have, definition number one, and basically they both say the same thing, it's a source of H plus ions. Isn't that nice? I'm getting notifications from Brigitte this morning on Teams. That's so nice. Don't worry, Brigitte. I'm going to give you the lesson very soon, so just hang on, okay? All right, so it's a source of H plus ions. The second definition, okay, is that it is a proton donor. Now, a proton, in case you're wondering, is also an H plus ion, because an H plus ion is a proton, right? Like if you take hydrogen and you remove its one electron that it has, all you're left with is a proton, right? So these two definitions are basically the same, okay? Now a base, on the other hand, definition number one, which goes with the two definitions correspond to each other. So a base is a source of OH minus hydroxide ions. Now you are familiar with hydroxide because we looked at it on the polyatomic anions. So hydroxide is what makes something basic. But the second definition is a proton acceptor. Now the reason why we need a second definition is because some things don't directly produce hydroxide. Okay, so what happens is they use the water to produce the hydroxide. Like for example, the example we used was ammonia, right? So ammonia, when it's mixed with water, it acts like a base. Okay, so what it does is it doesn't donate hydroxide to the water. What it does instead, okay, is it breaks up the water molecules and it takes the proton away from a water molecule. That's what ammonia does. And when it does that, okay, it leaves an excess of hydroxide in the water, because what's happening is when you break a water molecule, it's a water molecule. I'm just going to say it here. I'll just put it on the side. Look, note. Okay. A water molecule is HOH. This is water. Now, water can do both of these things, you understand? So water can produce an H plus and an OH minus, okay? So water can donate a proton, and it can also produce hydroxide, okay? So it's kind of an acid and a base, right? And when something's an acid and a base, we call it amphoteric, but you don't need to know that word. I'll let Mr. Ruddy explain that one to you in grade 11. But anyway, that's it. So water is kind of a special case where it does both things. But you see, water is neutral. It's neither an acid or a base because it does both things. Okay, because it contains both of those ions. All right, so now you know what an acid is, you know what a base is. But what about the pH scale? Well, some of you probably have heard of the pH scale before. It's a measure, okay, of acidity and basicity. Okay, so when something is acidic, it has a pH. Here, let me show you here. It's a scale for one thing. So the pH scale runs from 0 to 14. Okay, and here at 0, you would have, and I'll use the color red, you would have a, oh, it's not letting me, so anyway, I'll use black. You'd have a very strong acid. It has a pH of 0. Okay, now you can actually, like, you know, could you have a negative pH? We don't think that's physically possible in the sense that you can only get so much concentration of hydrogen ions in solution. Okay, I'll explain that in a moment. But anyway, it's getting weaker. So here, by the time we get to wine and vinegar and stuff like that, here it's weaker. So these are weak acids in this area here, a pH of 3.4. Now when you get to 7, and 7 is the number that's right in the middle of this scale, so I'm going to just put a little arrow going down here. 7 is neutral, which means it's not an acid at all. I don't know if you guys can hear those notifications, but thank you so much for spamming the group chat during my lesson. You know what? But hey, it's you, so it kind of goes with it. It's almost like you're talking during my lesson, so there you go. Anyway, so that's neutral. Now, going to the other side of the scale, the drain cleaner on this end is a strong base. Okay, it's a very strong base, has a pH of 14. Now, when you get here ammonia and milk of like baking soda and stuff like that, these are weak bases that have pH of 8, 9, 10, 11, that kind of thing. So these are weak base. And so what happens is, if you look at the scale, and I'm going to try to change color, okay, going this way, you're getting a stronger and stronger base. Going that way, you're getting a stronger and stronger acid. But right in the middle of the scale at a pH of exactly 7, you have water, basically. Okay, pure water has a pH of 7, and it's neither an acid or a base. We call that neutral. Okay, but basically, water has an equal concentration. If we go with definition number 1, here, the concentration, if it's neutral, of H plus equals the concentration, okay, of OH minus, that is neutral, right? Whoops. It's almost like you have positives and negatives, right? And when you have a total of 0, wow, my pen is not, I knew this would happen. Neutral, my pen, I need a new pen. I need a new pen tip, I should say. Okay, so there you go. So that's it. So there, neutral means an equal concentration of H plus and OH minus. And when H plus and OH minus combine, that's just water, right? So like if it's just water, you have an equal concentration of H plus and OH minus in solution, then that is neutral. So what we're talking about on this scale is a measure of the concentration of the ions. And what we're going to do is we're going to stick with definition number 1 today, okay? So we know that acids are a source of hydrogen ions, okay, H plus, but bases are a source of OH minus. So we're going to stick with that one today to explain the pH and POH scale, because this is the one that makes the most sense with this scale, okay? Now, I just want to give you a little note on what concentration means. Concentration, it's a measure of the number of molecules Okay, so my pen is really, my writing is normally bad, but number of molecules per liter, okay, in a solution. Now, the unit for concentration is actually a unit that you'll learn about in grade 11 called moles, but I'm just going to write, it looks like molecules per liter, okay? Moles per liter. So it's think about it for a second. If you had a certain number of hydrogen ions per liter, that's a measure of the concentration, right? How concentrated are those ions? Now, the more concentrated it is, the stronger the acid, right? And hopefully that makes sense to you. All right, so that right there is the two definitions, one for what an acid is, one is what a base is, and then what concentration is, okay? So that's it. Now, how does the pH scale work? Well, you'll notice that there's a weird little formula here. pH equals negative log of the concentration of hydrogen ions. Let me explain that, okay? Because you probably, in your journey through math classes in high school, have never heard of the log function before. Let me explain what, okay, the log function, what that means, okay? What is the log function? So in order to explain it, I'm just going to give you some examples. Okay, so look, let's say I have the number 10, okay? And on your calculator, just press log of 10. And what your calculator will say is that's equal to 1. Okay, now bear with me. Bear with me. I haven't explained it yet, but I'm going to explain it in a second, why the log of 10 is 1. Now, if you try 100, the log of 100 is 2. Okay? The log of 1,000 is 3. Okay? The log of 10,000, now I'm getting weird notifications on my watch. Okay, so the log of 10,000, excuse me, is 4. The log of 100,000 is 5. The log of 1,000,000 is 6. Okay, now watch this. In general, the log of, oh, actually, wait. That was getting bigger here. Let me do something else. The log of 1 is 0. Okay. The log of 0.1 is negative 1. Okay. The log of 0.01 is negative 2. The log of 0.001 is negative 3. Now, what does this mean? Okay, well, let me explain. The log button tells you how many powers of 10 are in the number. Okay, so for example, if I did log of 10 to the power of 3, now 10 to the power of 3 is 1,000, right? I already told you that the log of 1,000, I told you right over here that the log of 1,000 is 3, okay? Now, what about 0.01? Well, watch this. The log of 0.01 is 1 over 100, okay? Now, I'm going to write that as a power of 10. So it's the log of 10 to the power of negative 2, okay? So the log of, look at this thing here, okay, whoops, that, okay, like the log of 0.01 is the same as the log of 1 over 100, because 1 over 100 is 0.01, if you follow me, okay? Now, here's the thing. You can write 1 over 100 as a power of 10 with a negative exponent, if you remember your rules for exponents, that if you have a reciprocal, it's a negative exponent. So like, 1 over 1,000 is 10 to the negative 3. 1 over 10,000 is 10 to the negative 4, right? So I know that we talked about that in grade 9, and you should have done that in math in grade 9 too. So you should get that, okay? It should be all good. Now, what this tells us when you press the log of 10 to the negative 2, it just tells you what power of 10 it is, right? So it tells you the exponent. Get it? That's all the log button does. Okay, so that's what the log button does. Now, the pH function, P stands for like parts, so parts of hydrogen. Okay, so remember, what makes an acid is hydrogen ions, okay, in solution. So if I told you that the concentration of hydrogen ions, and we use the square bracket means concentration, okay? If I told you that it was equal to 10 to the negative 1, okay? Molecule, it's not molecules. A mole is like 10 to the 23 molecules, like because one molecule is incredibly low number. So it's like, don't think of it as a fraction of a molecule. That's not possible. So it's like, it's many, many, many trillions of molecules, okay? But anyway, we use this unit called moles to represent basically how many molecules you have. But it's actually a very large number, okay, what 1 mole is. We call it Avogadro's number. I'll just tell you. A mole equals 6.02 times 10 to the 23 molecules. Just so you know, but you don't ever need to use this number. You'll use it in grade 11 quite a lot with Mr. Ruddy, but I don't want to, we can't do everything. I can't spend this entire course talking about chemistry, so some things we have to save for grade 11, okay? So you're already getting a good head start. But just so you understand basically what a mole is. But you're not going to need to know that number to do this calculation, okay? So watch. Let's say that's the concentration, okay, of, and by the way, this would be a very dangerous acid if it had this kind of concentration. What I'm talking about is 10 to the negative 1. Or if you don't like writing it as a power of 10, then just write 0.1 moles per liter, okay, like that. So if that's your concentration, well, the definition of pH is equal to the negative log of the concentration of H+, okay? So it's equal to the negative log. So what you do is you just take out your calculator, right? Now I can't show you a calculator on here, but because as soon as I do that, it'll end my recording, so I can't show you the calculation like that. But what I'll do is I'll just ask you to take out your calculator. You're going to go like this, negative log, and then enter the number 0.1. And we already know that the log of 0.1 is negative 1, right? So this is equal to negative of negative 1. Well, that's just positive 1. Now, a positive 1, okay, means, if you go back to the scale that I show you up here, a positive 1 is stomach acid, okay, which is a very strong acid. In fact, like that, the acid is very similar. pH of 1 would be something like battery acid, okay? So it would be, caustic, like it could actually dissolve a piece of zinc or something like that, right? And so that's your stomach acid, and it has a pH of 1. So you get how they get these numbers? The numbers show you the concentration of hydrogen in solution. Now, if you have a pH of 7, okay, now for something that's neutral, so you watch this. Once you understand that the numbers in the pH scale are just powers of 10, now we know how to find the concentration then, right? So we know neutral has a pH of 7. So therefore, the concentration of hydrogen ions in a solution that is neutral has to be 10 to the negative 7 moles per liter, okay? And that would be neutral water. So neutral water has a concentration of hydrogen of 10 to the negative 7 moles per liter, okay? And that's it. Okay, so we know that this, number 7 here, no, I'm sorry, that looks horrible. Let me zoom in a little. That number 7, okay, that still looks bad. Here, I'll use a different color so it's not so confusing. That number 7 goes in as the exponent, as the power of 10. So what I'm trying to tell you, long story short, is these are all powers of 10, these 14 numbers, Okay, so for example, if it's drain cleaner, the drain cleaner, okay, I'll write it in red, drain cleaner has a pH of 14. Okay, so that means therefore the concentration of hydrogen in that solution would be 10 to the negative 14 moles, moles per liter. Okay, so if that makes sense to you, very good. Now, what about POH? Well, we can play the same game because H plus and OH minus, they play this little game in solution with each other because when they combine, they form water. When you have more, okay, like here, let me give you a little summary here. Okay, let's talk about POH. It's a small p, capital O, capital H. Okay, so I'm just going to tell you that it goes like this. Okay, so we normally don't show a POH scale. Usually we just use the pH scale, but the POH is part of it too. Okay, so if it's an acid, the concentration of H plus is greater than the concentration of OH minus. Okay, if it's neutral, neutral, the concentration of H plus is equal to the concentration of OH minus, right? Now, if it's a base, the concentration of H plus is less than the concentration of OH minus. And you guys know the less than symbol, right? Right? And the greater than symbol, like Flynn is greater than, much greater than, like Steam, right? You remember that. So you should be familiar with these symbols by now, but that's it. Okay, so that's how it works. Now, so there's a little game they're playing in solution with each other. If you have an acid, you just have more H plus than OH minus, and that makes something acidic. If you have a neutral solution, they're equal in concentration, but if you have a base, you have the more of the hydrogen ions compared to the hydroxide ion, or sorry, more hydroxide compared to hydrogen, okay? Now, there's an important note, and I'll write it in red. The pH plus the POH always add to 14. Okay, there's sort of this magic number 14. They always add to 14. So, for example, let's say you have a pH equals 1, right? So, therefore, the concentration of H plus would be equal to 10 to the negative 1 moles per liter, right? Like that's what we just learned. So that number 1 would go in to the exponent there, and you just change it to a negative exponent because the pH is a negative, like it's like the negative log, okay, and that's why there's always a negative sign there. Okay, so that's it. Now, what about the POH though? Well, since the POH and the pH add to 14, okay, therefore the POH will equal 14 minus 1 equals 13, and what that means is that the concentration of OH in solution would be 10 to the negative 13 moles per liter. Okay, so that number 13 goes in there. So anyway, the whole point is, just like pH is the concentration of hydrogen, well, POH is the concentration of, a measure of the concentration of hydroxide in solution. Okay? All right, so that's basically the lesson for today. That's everything you need to know, okay, for the lesson for today, pH, POH. And the point is, the more hydrogen you have in solution, the more acidic something is. The more hydroxide you have in solution, the more basic something is, okay? And so just looking at this scale again, here you can see, like, just look at what they're talking about. Hydrochloric acid at one end of the scale, or sulfuric acid, or battery acid, whatever have you, very strong acids on one side. Stomach acid, lemon, juice, vinegar, okay, wine, coffee, milk, and then water. Water is neutral. Okay, so everything's an acid, everything I just read off to you. Then you get to water, which is neutral. But then blood is slightly basic, interestingly. Okay, has a pH of around 8. Okay, baking soda, pH around 9. Okay, milk of magnesia, which is an antacid. It neutralizes acid, makes sense because bases neutralize acids, right? So milk of magnesia is 10. Ammonia is a cleaner, it's 11. Soap is 12. Bleach is 13. Okay, and drain cleaner is actually a pH of 14. That's a very strong base. So there's your scale, and now you sort of understand what's going on in this scale, right? So 7 is neutral, less than 7 acid, greater than 7 base. Okay, just remember that, and just remember how to use this log button. It's kind of cool. Okay, and just also remember that the pH and pOH add to 14, like you saw down here, and so they're playing a little game like who's greater in the solution, the pH, the pOH, right? So which one has higher concentrations? If it's an acid, H plus has a higher concentration. If it's a base, the OH minus has a higher concentration, right? So let me show you the worksheet. So last week I gave you a worksheet, okay, on acids, bases, and salts. Okay, I don't know if I gave you this one, to be honest. Did I give you this? Let's see. All right, this is just a summary. I think we'll do this together, okay, tomorrow. So yeah, we can look. You can take a look at that if you want. Actually, here, I'll assign this as a. Since you have nothing to do today, I'll give this as a little assignment. Okay, what are acids, bases, and salts? Okay, Arrhenius definition: an acid forms H plus, right? So like just as a little summary. Anyway, I'll let you figure out the rest of it here. A base forms OH minus in solution. Okay, that's what we just talked about. So that's the Arrhenius definition. Now classify each of the following as an acid or a base or a salt. Like salt is if it doesn't have H plus or OH minus, but it's still an ionic compound, then it's called an ionic salt. So let me give you some examples. This is an acid. This one's a base. This one's an acid. This one is a salt. Okay. Why? Because it doesn't have H plus or OH minus, right? So it just dissolves to form ions. It's just not H plus and OH minus. This one should be an acid, although that's a weird polyatomic anion if it is. FO4, I've never heard of that one. Anyway, I guess it's a perfluorate. I guess you would call it that, right? Barium hydroxide would be a base, right? This one is a salt. Okay, this one is acid, salt, right? Salt. Potassium acetate, right, would be a salt. Sodium chloride is salt. That's the one that you eat. Okay, but you get it, like if it produces H plus ions, it's an acid, OH minus, a base. Everything else that's ionic, a salt. Okay. Anyway, I'll let you fill in that. That's not a big deal. What I want you to do instead, okay, like that'll only take you a few minutes, just a little summary in your notes. Okay. All right. So here's the pH scale. Okay, now in order to do this, I'm going to do some of this with you. You're going to need a calculator. I'm going to go get my calculator because it's in my hand. All right, so I'm actually at St. Matt's, by the way, recording this. We still have to come to school, but I don't mind. You're not here, so it's perfect. Okay. Anyway, take your calculator and go 0.02. For me, some of you, you'll press the log button first, but here's the concentration of hydrogen in the solution, right? So take your calculator, type in 0.02. For me, I would first type in the 0.02, then I press log, okay? And what it tells me is, it says negative 1.7, right? But pH is the negative of that, so you're going to write a positive number. I'm going to write 1, whoops. Let me go back to a normal pen. I'm going to write 1.7 here, okay? Now, the pOH, the way to find the pOH is you're going to go 14 minus 1.7 because they add, oops, 1.7. Let me zoom in a little. And so I'm just going to go 14 minus 1.7, I get 12.3. So they must add to 14. So if the pH is 1.7, the pOH is 12.3. All right, now look at this. The next one is a base. How do we know it's a base? Because it's sodium hydroxide. Hydroxide is a base. So that number 0.005 is going to tell us the pOH. Okay, so I put 0.005, or sorry, yeah, 0.005. Then I press log, and it says negative 2.3. Okay, so I'm going to write positive 2.3 because it's a negative scale, right? Oops, I keep forgetting to do that. So I'm going to write 2.3 in here for the pOH. I got that with the log button. Now, since the acid and base have to add up to 14, I'm going to go 14 minus 2.3, and I get 11.7. Okay, so that's it. Now, if it tells you what the concentration is here, 7.2 times 10 to the negative 8, you have to use your calculator. First, I put in 7.2 exp8 negative, then I press log, and I get negative 7.14, but I make it positive, so this is 7.14. And all you're doing is pressing the log button on your calculator. You don't have to know exactly what it does or anything, just press the button, that's it. Now they have to add to 14, so my pOH I get by subtracting from 14. This one's going to be 6.86, right? And that's it. So I'll let you do the last one. And you guys are superstars. You're getting it, right? I'm imagining that you're getting it, so it's all good. All right, now in the next example, you're doing the opposite. They give you the pH, okay, and you have to just fill in the rest of the blanks. So first, this one's really easy. You don't even need a calculator for it. But for the pOH, we're going to subtract from 14. So notice here it says the pH is 2.9. So I'm going to go 14 minus 2.9. I'm getting lazy using a calculator for that. This is 11.1. Okay. Now to put the concentration of H plus, I just have to go 10 to the power of negative 2.9. So this number 2.9 is what goes into the exponent. And for the the concentration of hydroxide, I go 10 to the negative 11.1. And it's this number here that goes into the hydroxide. Okay, that's it. Now the pH of sauerkraut, which is something that I can't stand, but anyway, the pH of sauerkraut is 3.85, right? So again, I'm going to subtract from 14 minus 3.85. I get 10.15. Whoops. Okay. Now I can write my powers of 10. So this would be 10. The concentration of hydrogen would be 10 to the negative 3.85. That number there goes into the exponent. And over here it would be 10 to the negative 10.15, which goes in here. Okay, now you can actually enter that into your calculator and see what the decimal is, but don't bother, just leave it as a power of 10. Okay, all right, now which of the solutions are acidic? Well, the ones that have a pH of less than 7 are acidic, right? So that's it. A certain brand of root beer has a certain concentration. I'm going to let you do the rest of that, okay? And I'm just going to do some of the table on page 2. So let's look at page 2 here for a second. So if your hydrogen is 1 times 10 to the negative 3, that would have a pH of 3 and a pOH of 11. How did I get that so fast? Well, because of an even power of 10, right? And so all I have to do is look at the exponent. The pH tells me what the exponent is. I just make it positive, 3. And then they add to 14, so 3 plus 11 is 14. This is definitely an acid, okay? And the concentration of hydrogen would be 1 time, here, I forget writing 1. I just write 10 to the negative 11. So that's this number for OH goes into the exponent, okay? Now here, they give us the concentration of hydroxide, so I'm going to write 6, okay? Now they have to add to 14, so that means the pH would be 8. This is a base because the pH is greater than 7. And I'm going to write here 10 to the negative 8. It's this number that goes in there for the concentration. So you see how easy it is? Okay, now if the pH is 9, right away I'm going to write 10 to the negative 9 in for my concentration of hydrogen. The pH and pOH add to 14, so that has to be a pOH of 5. Okay, this is definitely a base because the pH is greater than 7. And I'm going to write 10 to the negative 5, okay, as my concentration of hydroxide in solution. Don't forget, it's the pOH that tells us the exponent there. And I will let you do the rest, okay? I'll let you do the rest. So that's it. Now, there's one more thing. The sheet I gave you last week, I think, was this one. And we did some of it together. I told you only to do page 1, but now you can do page 2. Now, by the way, this weird thing is H+. Okay? So what you would do, let's do the first one together. You would punch this number into your calculator, 2.35 exp3 negative. Okay, and then I press log. I get negative 2.64, so I'm just going to write 2.64, okay, in here for the concentration of hydrogen. Then I'm going to subtract that from 14. I get 11.36, so that's 11.36 for the pOH. This is definitely an acid, right? And the concentration here would be 10 to the negative 11.36. Okay, and remember for concentration of OH, you just use that number. So anyway, there you go. Okay, it's all good. So you don't have to show your work in steps or whatever, you're just doing it, and you don't have to do the bonus or anything. But I would like you to try these 3 questions here, but if the bonus is optional, okay? Yeah, don't bother. Some of this is a little bit above the grade 10 level, but I think you can do the chart. It's pretty easy, okay? That's it. Okay, so guys, I hope you enjoyed this. It took me 37 minutes to make it, and that's a precious 37 minutes of my morning. Yeah, I mean, I just wanted to explain to you pH. I do expect you to watch it. I do expect you to complete the worksheets. Now, am I checking all these worksheets tomorrow or anything? Well, please try to do like some of it so that you've tried everything, right? And maybe if you haven't finished everything because you're still studying for the quiz, but anyway, you're supposed to be writing the quiz today, so yeah. Anyway, give it a shot. Try to fill in the whole thing. It actually doesn't take very long, okay? But just do the best you can. And our final quiz will be on this information. We only have one real topic left. We're going to talk about acid rain, okay? And how you mitigate acid rain, and how we fix the problem in Sudbury. And I know we talked about this in grade 9, some of us, okay? But we're going to go over that again, since now we're actually talking about acids. We can have a more sort of intelligent conversation about it. But yeah, so, and that's our last topic in chemistry. And then we'll have one more test on acids and bases, like on these worksheets basically. So hopefully by the end of this week we'll be doing that. And that's it. All right, so enjoy your snow day. Okay, enjoy that time at home. And thank you for giving me like 38 minutes. Okay, so anyway, I will talk to you tomorrow. And don't forget, we haven't forgotten about like the birthday wheel and stuff like that. We just haven't had any opportunity to do it. Okay, so we'll definitely make some opportunity to do that starting tomorrow. All right, guys, have a good day. We'll talk to you soon.